So I've been programming for a while. I first was shoved in front of a basic interpreter when I was about 8 years old, and sort of got hooked and didn't stop. And I really like creating software. But one of the things that I've realized as I've gone on over the years is that writing the code is only just one part of this. Actually, a really big part of developing effectively is about getting a process in place that lets me develop in a sort of efficient way, that sort of helps me along the way and takes away a bunch of the stuff I have to worry about. So that's what I'd like to really focus on in this talk. I like an optimal development process because it helps me to get stuff done. It means I can find the bugs and mistakes I make and fix them sooner. Nobody writes bug-free code, so we have to sort of manage those things. In pretty much all the projects I do, I'm not alone. I have some other people I'm working with. Depending on the project, they may be sat just down the office, or they may be scattered all over the world. So, it's good to get a process in that sort of facilitates that. And of course, it's nice to be able to finish my work sooner, and then I have time to go to the pub and have a drink. But optimizing the development process actually takes a little bit of effort. And a lot of what I see is this. We're too busy on the next deliverable to spend time on tooling. It's sort of a focus on the short term that sort of ignores the, not even necessarily long term, but what they call medium term savings. It's not necessarily going to save you tomorrow, but within the next couple of weeks, yeah, very possibly. Now, continuous integration sounds like a big thing, but part of what I want to really talk about today is that actually you can work incrementally towards it and actually get some incremental benefits as you go along. So what I'm going to do, I'm going to just spend a while discussing what actually is integration and what is continuous integration. What's this all about? Then I'm going to step back from that and just look at various steps we can go through that sort of get us from zero to sort of a good state of using continuous integration. And we're going to look at all of these steps, particularly the first couple in some detail. And then we'll just finish up with a little review and the pros, the cons, and so forth. So what's this all about? Whenever we develop software, we make changes. The change might be to fix a bug. The change might be to add a new feature. The change might actually do neither of those. It may just sort of refactor the software a bit so that we have the ability to make some changes in the future. Now, on any big project, or even a smallish one, multiple people will probably be making these changes. And at some point, we have to bring a couple of people's changes, or lots of people's changes, sort of into one coherent bit of software that we can make a delivery of. And that process is integration. One of the memories I always have back at university, so we had to do these group development projects. Now, my team was awesome because it had me in it, and we decided that we, on day one, would sit down and write a bunch of interfaces to sort of define the sort of boundaries between the bits of the project that everyone would work on. And what happened is we kind of got to the point of integration. Everyone had programmed against the same interfaces, just with some dummy objects along the way. So the integration took 15 minutes, and we went for a beer. Many teams that I heard of told me their nightmare stories of how they'd spent all night trying to pull everyone's work together into something they could actually present. And yeah, they didn't get to go to the pub. It was closed by 4 a.m. Poor guys. Integrating lots of different changes, and especially large ones though, can be challenging. If two things don't work together, it can be hard to track down why. If you've sort of been building stuff for weeks and weeks and weeks, and you sort of never try pulling them together, then it's going to be a difficult problem to try and do that. People have forgotten what they were doing. And that's kind of one of the sort of problems that's sort of at the people level, but also you can get issues with your tooling as well. So if you have a version control system, which in theory is there to help you pull all the different bits of work together, and it actually gets in your way in doing so, this can sort of present a challenge for us as well. So that's one of the challenges I'd like to sort of talk about today. In continuous integration, we actually sort of challenged to change the way we think about commits. it's kind of interesting that a lot of the sort of shifts that we can make in sort of improving our development process are actually in many ways just changes to the way we look at things that we maybe already do. So I expect that a lot of us are using version control, and so we do commits. But it's kind of nice if you step back and stop looking at commits as, it's 5 AM, so I just shove some stuff in the repository, and say, well, a commit should be sort of a single unit of change that I want to introduce and integrate into the project. So that you're sort of encouraged to very regularly break your work into smaller chunks, so you can do bits of integration quite often. And then as we sort of get further along with that, we can look at saying, well, why don't we do an automated build and an automated test run of every single commit, so we get rapid developer feedback. So continuous integration is very much about the idea that we try to make integration something that we're always doing. And we're always doing it very incrementally, and we sort of try and build ourselves infrastructure that gives us value from that. Because, okay, a lot of the time, you can sort of twiddle with your development process and say, okay, we'll sort of do this, it's a best practice. But if you don't then build the stuff that you need to exploit the value from that, then it sort of misses some of the point. So I'd say step one is get version control. So let's be a bit interactive. I know it's been a long day so far, but let's just see and have some hands up. How many of you are using version control? Let's see. Okay, that's a lot of hands. That makes me happy. How many are using source safe? Yeah, some hands. Cool, folks. Anyone still using CVS? Okay. So I guess a lot of the people who weren't using CVS moved on to SVN. Do we have people using that? Yep, some, okay. Who is using SVN and really loves working with branches and finds branch merging in SVN really pleasant? That doesn't seem to be much hands there. Yep, I wouldn't put my hand up at this point either. Anyone using TFS? The first time I gave this talk, so we did this event in Malmö at the end of last year, and I'd actually just started consulting somewhere where they used TFS, and at the time I sort of had this sort of, I'm not too keen on this. And by now it's just sort of, do not want. Any of you using what I call a distributed version control system? Something like Git or Mercurial or Bazaar or Darks or any of those? Anyone? Okay. So, before I dig into a little demo I want to show you here, let's just sort of unpack version control a bit. So version control is really essential if you're trying to get a bunch of people developing software together and you don't want to lose or damage each other's work. So this is sort of one of the sort of main reasons we want to do this. If two people change the same file, then we'd really like it that we can sort of merge the changes from different bits of the file together, and we'd kind of like that to just happen for us, unless they actually conflict and we really do have a genuine issue to deal with. A good version control system should make merging changes that really don't need human intervention completely trivial. Even when they're made in the same file, even when multiple people have come and changed the file in various different ways, if those don't actually have some overlap that sort of change the same area of the code, we'd really like it that, that those changes are just merged for us. Now, another benefit of using version control, and something that we would want a version control system to help with, is that we can go back to our software at any point and sort of be able to just go and produce sort of a bug fix release. So suppose I released, say, version 42 of my software, and we get busy and start hacking away on version 43, and then, 2 weeks into this, we've committed loads of stuff. A customer calls and says, oh, I just found a really nasty bug in version 42. We don't want to go and give the customer like a bug fix plus all of the half-baked stuff we've been working on. We want to be able to go back to the commit where we did the release, branch it from there, do our bug fix, and then we can give them the release from this branch and integrate the fix back into sort of our main sort of trunk or master or whatever we're calling it. So that's kind of one of the things that we'd really like to be able to do as well. All these kind of nice workflows in terms of working with different versions of our software. Another benefit, of course, is that you can view a full history of who did what and when and why they did it. So good version control actually is sort of a starting point for us maybe to do some code review. So we can go and say, this change came in and this was what was done, and then we can go and sort of look through it and maybe spot some issue. So this is a really common workflow. So that a lot of the stuff I develop on, we use a site called GitHub, and actually it just gives you a list of all the commits, and you can go and look at one, and you can go and see exactly what changed, and then you can go and write a little comment against a particular line of code and say, why on earth did you do this? Or, oh, awesome, this is a really great fix. And it'll get an email sent off to the person who did it. I'd like to just talk about a couple of best practices in version control. Commit frequently. Now, I don't know if you can see that from too far back, but that's a commit log of mine. And you'll maybe notice that all of those are on the same day, and there was a bunch more of them. Okay, so it's really good to sort of break your work into little pieces and commit it regularly. It actually fits in very well with the agile approach overall, where we sort of try and break things down into sort of smaller tasks and smaller deliverables that we know and can estimate how long they take. Well, if you try and make each bug fix and each sort of increment of functionality a commit, then you sort of get a commit log which gives you an idea of exactly what's going on. The other thing you can start doing is you can start doing things like cherry picking, where you say, oh, actually what I'd like is to have this feature developed in this branch over in my other development task. And if you have gone and done really good semantic commits, then that's a possibility. Avoid actually breaking tests or the build in your sort of trunk or master branch. Okay? So the idea here is that we will try to always have our master branch in a state that potentially we could ship it. It might not be polished, but at least it would build and it would pass the tests and we could release it. So this is sort of something to aim for, that we don't get our software into a state where there's no version of it that we could ever conceivably sort of show anybody. It sometimes is the case that you actually need to sort of break things up into a sort of bunch of chunks and do them step by step, but you're going to break the software as you go. That's fine. Just do it in a branch, so that the sort of mainline code is sort of kept in working order. Another thing, so I talked about how it's good to sort of focus on getting your commits to be sort of very feature-based or very sort of semantic. Well, one of the other things that goes with that is writing some kind of descriptive commit message. In a sense, your version control is sort of like a chronicle, a history book of everything that's happened to your software. And it's really nice if you actually go and document what you did. So someone coming and looking back at it 6 months later, and yes, that happens, can actually go and look at the history and say, okay, I understand the motivation for where this particular bit of code came from. It was introduced to do this, and so forth. One of the things I like to do as well in any big complex system is just adopt a little convention that lets me sort of identify what the commit was related to. So if you have your system in some kind of subsystems, you could just put a little sort of name of the subsystem in square brackets or something into your commit message. Then if you want to find all the commits that affected a given subsystem, all you have to do is take the commit log and just filter it out for anything with that tag in it. It's a really easy thing to do, but it's actually very valuable. Some common pain points I've seen. One of them is that exclusive locking is really limiting with concurrent development. So I see this one happen a bit. This is often a situation in the office, one of the offices I'm in, that somebody will have an exclusive lock on a file in version control, which means nobody else can change it. The silly thing is that it's a file that's just an XML file that Visual Studio very carefully writes so that you can merge it easily. And yet they sort of hold this thing under lock. Now, half the time when I go and track down the person who's got it and say, oh, I need to edit this file,